Okay, we're going to get going tonight. Welcome to Respiratory 121. This is medical gases, aerosol, and humidity therapy. My name's Tim Dunkley. I'll be your instructor for this mod. Whether you're tuning into this later or going to tune in live, welcome. Welcome to the class. Happy to have you here. There's much for you to learn in this mod, and it's going to be excellent preparation for you down the road once you all become respiratory therapists. So a little bit about me. Like I said, my name's Tim. Please call me that. I've been a respiratory therapist for over 14 years now, working on 15. I graduated from Weber State University. It's in Ogden, Utah, with a bachelor's degree. I've had exposure in respiratory care, you name it. Neonatal ICUs, adult critical care units. I've worked air transport. I've done outpatient testing. I've done a little bit of everything. So hopefully I can use some of my experience to bring to the table to help you all to get a feeling for the business and things of that nature. I currently work as a clinical educator and clinical coordinator at a 130-bed hospital. We have 24 level 3 NICU beds and 20 ICU beds, cath labs, CVOR, all that good stuff. So get to do a lot of fun stuff there. We get to do innovations, art lines, things like that. It's an exciting place to work, and hopefully some experiences and case studies I've come across there can share with you. I also have background from the EMS side. I worked as a firefighter for the past 17 years as well. So kind of busy juggling those two gigs, but also gives me some experience and hopefully provide you guys some insight into different patient care experiences, and 17 years of that and almost 15 as an RT. All these thousands of patient experiences I've had over the years. Hopefully I can provide some insight and help for you as we work through this mod. As far as personal life, I like golf, outdoors, that sort of thing. Being in Utah, lots of fun snow to ski and trails to mountain bike and everything in between. So that's a little bit about me. As far as getting a hold of me, please do. I have all my email and everything piped through my phone. Like I say, I have a pretty busy life. So if I don't get right back to you, just be patient. Probably the best way is via email. There's an email link or opportunity in Canvas that if you email me from Canvas, it links up to my IU account, and I'll get that email. You can call me. Always leave a message if you call me, because if I don't answer, I need to know what class you're in and who you are and your question, and I'll get back to you, either call you back or I might even text you. You can also text me. That's fine. That's a good way. I will say that there's a little messaging in Canvas. It's like if you access off the grades and pull me up and try and message me off grades in the comment section, unless I'm physically looking at those sections, it doesn't link to my email account or anything. So I get once in a while, I'll have a frustrated student that says, "Oh, I've messaged you and you never got back to me." And if it's in that little realm, I won't see it unless I'm specifically in the grade screen. So try and use the email or text me or call me or whatever like that. As far as your purpose here, I can't stress enough that yes, it's important that you all get a degree, which is an important part of your career path, but most importantly is passing the NBRC TMC exam. And when you pass that exam, to pass that at that higher cut. The higher cut score is the higher score, which is the RRT level score, and then that lets you take your clinical portion. That's your goal, and it's my goal as one of your many instructors to help you guys prepare for that, to pass that exam. Because once you pass that, you get your license, you start working and start making the money, which you know, I get that we're all here for the patient experience and helping people, and that's what I love about this job, but the paycheck isn't too bad either. And so that's what I want for you. That's my goal, whether it's in this mod or another one. If you ever, you know, need to get a hold of me and you need some help, you have a question from another class, whatever, know that I'm always a resource for you. I'm here to help you all. I want you all to do well. I'd be thrilled if I could pass out A's to everybody, every single mod. And all you need to do is climb aboard and work with me and do your stuff, and you can do that quite easily. So keep that in mind. That's the prize, is that NBRC exam, taking that, passing that, getting your license. You can see there those states, California, Ohio, and Arizona have already passed legislation to be licensed in those states. You need to be an RRT. And Oregon's well on their way. And with anything, if states start seeing other states that aren't these states start falling and seeing, you know, what's going on, they're going to soon to follow that that's the higher level that you're a cut above, and that could spread across the nation over the next decade. So keep that in mind. And by the time you're done with this program, that should be no problem. Having seen behind the scenes here, there are a lot of really awesome, dedicated, really smart people working very hard to help you guys along, to make sure that you're prepared for that time when you sit for your exams. So I'm excited to be a part of it, and I'm glad you guys are here with us. Just talking about Canvas, you should have some experience from other courses in Canvas. If you have any issues or something's not loading, keep in mind that you have that student IT helpline. Those guys are really awesome. It's a rare week that I don't have an issue, that I don't utilize them for my computer or something that I need or what's going on. So make sure you utilize them. If you do have problems with assignment or whatever, get a hold of me, say something's not working on Canvas. Some of the daily checkpoints, that sort of thing, sometimes they won't load. Please email me and let me know those so I can get a hold of who's in charge of it so we can make that work for you. Because stuff will happen, you know, being an online university, there's stuff that's going to happen. Your internet's going to blow up, the power's going to go out, something like that. So the most important thing is to get in touch with me and let me know what's going on. I've already had a call today from a student that's had to fly out on a family emergency, and you know, that stuff happens, and no big deal. We will work it out. Families first. Having said that, do your best effort to get what you can done, and we do have some policies and things to adhere to. So I'm as flexible as I can be. We talk about this particular mod. You'll have your discussions. Keep in mind that in your discussion forums, you're going to post an answer to the question in the discussion forum. You might have already looked at that today. That needs to be an APA format. It needs to have citations, and you need to answer the question that is asked. And I know you're all thinking that sounds pretty simple, but the responses I always get are not addressing the question that was asked. So definitely need that. That needs to be done by Wednesday night, that original post, and then you need to post it to other of your classmates, and that needs to be on a different day so that you show me as I'm doing your grades that I see different dates there. And that just shows me that you're getting in on different days and reading everybody's posts. To be honest with you, I really like the discussions because that's where I think a lot of teaching and a lot of learning takes place, that you learn from each other. You'll see me, I'll post 2 of my own posts during that week that aren't really related to the question. It's just respiratory stuff that I think is pertinent to our discussion or to the mod, or it might just be something I saw that day and I was like, I need to share that with my students. So the discussion I think is really awesome. It's a good way to learn, and so make sure you take advantage of that. Within each one of those, there'll be your question and a reminder of how long it needs to be. Again, make sure you're putting all that stuff in APA format, and please turn it all in on time, so I can give you the most points possible. Next, there's DC, and that's the daily checkpoints. The daily checkpoints are worth 5 points a day. It's usually some reading or some video or something. And then there's a quiz question after it. So you need to do 4 or 5 of those for the week. I believe it's 4. And go in and read through that. Some of it is related to like student finances. Some of it's related to respiratory. It's all pretty good stuff. It's good information. It seems like a lot of the students will do those just every single day just to take advantage of what's offered there. If you have questions on that, there's some links once in a while that don't load off those. So keep that in mind. So Jill has a question. Do discussions need to have reference in the cite text with APA format? The answer is yes. When you answer your questions, you need to do a little bit of research on those. And so within that, yeah, at the bottom, you'll see you'll have to put your APA citations and in your post where you used it. Does that make sense, Jill? Moving on to assignments. So we'll have an assignment a week as well. Jill says yes, cool. Thanks for sending that via chat, Jill. Yeah, if you guys have questions here that are live, please fire off a chat or whatever you want. You can tune in on your mic too and tell me to hush and ask the question as well. Onto the assignments. You'll have a little bit of reading, and then the assignment will have a question. Those need to be 500 words. Those also need to be in APA format. Use your citations. When you submit those, there's a program that the university uses called Unplag, and that is a program that runs all the stuff that you wrote and compares it basically to the internet, and it gives me a percentage of what's yours and what's not. Obviously there'll be a little repetition in the questions and so I expect that, but anything that you cite, it also shows me that that's made the program happy as well. So having said all that, don't plagiarize, cite what you use, and you'll always be fine in your college experience and after that. Plagiarism is not tolerated, and I'm sure you've all had that in your orientation. So yeah, just cite it correctly, and you'll be good. That's part of the experience is learning and growing and studying and doing research, and this course is always as is the case as well. And then on the assessments, Assessment's a fancy word for the quiz. The question I always get is how do we do well on the quizzes? As you'll find each week, there'll be a summary. You can either access it through your syllabus in Canvas. That's going to give you a rundown of what's going on for the week. There'll be some videos in there, some links, some stuff to look at. And it's all really good stuff. And if you'll read the chapter for the week and pay attention to my lecture, quizzes should be no problem in this class. I obviously have access to the quizzes, so I do like to cater my lecture to what's on those quizzes, and you'll probably find some pearls throughout the lecture that you'll think, you know what, he said that right in the lecture. So maybe a little incentive to listen to the lectures and try and buckle down for 60 minutes each week, and I'll try and not put you to sleep. Notice I don't use the video, so you don't have to look at my mug talking to you. It's probably be offensive to some. So anyway, so that's just some housekeeping stuff there. Christy's already asleep. Sorry, Christy, I put you to sleep. I appreciate you guys tuning in with the chats. I like the humor, and that makes life a lot better for me as I stand here and talk to my computer. So anyway, you know, we've got Christy and Jill in here tonight, so happy to have you guys. So let's jump into it, shall we? Like I said, if you guys watch this and you're not live and something comes up, please don't hesitate to get a hold of me. So let's start off with physics for respiratory care. As I was saying earlier, we're going to talk about lots of really pertinent stuff in this business about medical gases, aerosol, and humidity. What you're going to learn in this mod is stuff that's going to stick with you clear through your careers. I think about respiratory school 16 plus years ago. Some of the stuff that I'll be teaching you this mod is stuff that I learned, you know, my first few semesters of respiratory school, and I still use this stuff every day in the business. And I think that's what's exciting when you're finding this point is you've decided on your career and what you want to do, and you can start applying all this stuff right to the business. So we're going to talk about some physics stuff. Everybody's thinking, great. So it's physics, and it's also some chemistry. So we've got states of matter. We've got solids, liquids, and gases. We're going to interact with this stuff as we try and ventilate folks and move gases in and out of lungs and through airways. And we're going to be working against liquids. We're going to be working against solids when we do that. So we kind of need to have a handle on what each of these substances are defined as. So the first thing, liquid, when you think about liquid, that's not the first one. Let's talk about solid first. First thing we talk about solids, is they're going to have a definite shape and a fixed mass. When we look at liquids, they're going to have a fixed liquid, but not a, they're going to have a not a fixed shape. They're still going to have a fixed mass. And then gas is going to be movable and also is going to take the form of whatever it's in. And then we break it down a little further, and we have atoms, molecules, and compounds. So looking at atoms, the smallest substance and still retains all the stuff that makes that stuff. Molecules are a group of those atoms. And then we have compounds, which can be different types of atoms that come together to make something. So if we talk about hydrogen is on the periodic chart as H, and it's H1. That's the smallest. Building block, and it still keeps itself as hydrogen. Those hydrogens can come together to form a molecule of hydrogen, and then if we put two hydrogens and an oxygen together, we just made a compound, which we all know is water. So probably pretty basic stuff for everybody, but important nonetheless as we start to build on some of these concepts. So we talk about work now, and a good definition of work is force that applied to an object that moves that object. And we're going to be moving objects as respiratory therapists, and that object oftentimes is gas that we're going to move in and out of a human being. And we're about the only folks other than your anesthesiologist in the hospital that know how to do that. And so it's kind of a fun thing to be able to do. So if we talk about applying that to our respiratory world, and we talk about work of breathing now, is that energy expended to inhale and exhale a breathing gas as we bring that gas in and out of those airways down into those lung fields. That's the work we're performing to do that. Work of breathing also can be defined down the road when we start looking at patients as they have an increased work of breathing, or they're working harder to make that happen. And that's when we need to intervene to help them so they don't fail on us. And that'll be coming down the road. We'll talk more about that. So energy, obviously the ability to do work, all kind of review stuff still, but all important as we start to put all this together. Pressure is a definition we need to remember, and that is the force per unit area that one region of a solid, liquid, or gas exerts on another. So as RTs, we need to understand pressure and the good and the bad that we can accomplish by using that if we have too much or not enough, and put that together here in a second as well. So now we have work versus kinetic energy. So we've kind of defined work, and if you guys think about kinetic energy, that is energy in motion. And so if we have something moving now, we can do harm and we can do good with that energy of motion, whatever we're moving. And so make sure all these separate concepts that you just go back to the table or in the chapter and just do a quick review of all these terms, and make sure that you have a bit of a handle on it. There will no doubt be some of this. We'll come back to you as you look at your quiz. So thermodynamics, that's also called the law of conservation of energy. If you remember, thermodynamics is that as we have energy transfer, that it can't be created or destroyed. And that's an important concept because we're going to be using energy to move gases around, and these different reactions and changes that we're using all takes energy. So if we come back here to our solids, liquids, and gases, usually we say if a liquid's going to a solid, it's freezing. If a solid's going to say, a gas and its sublimation. If a gas is going to a liquid, it's condensation. All those different levels take energy to do that. And so when we come back to thermodynamics, know that as energy is changing up and down these levels, that it's not created or destroyed, it just changes form. So somebody that remembers back from chemistry remembers when they talk about, well, some of that is lost, and yeah, there's a name for that. It's called entropy. So impress your friends with that one if you don't remember that. But I don't recall anything on the quiz for that. So we start talking about all this stuff. We need to focus on how we're going to define all of this. And this is the SI units. And these are all been kind of accepted in the community around this planet of ours of how we're going to define these units in what we call the SI, or Standard International Units. So distance there in meters, time seconds, mass in kilograms, current in amps, temperature in Kelvin, force in newtons, electrical charge, we're not going to talk a lot about that one, energies in joule, pressure in pascals, and then electrical potential we'll talk about in EKGs, but not necessarily in this mod. So make sure you pay attention to those, how they're written, and we'll start working with some of these terms as we start putting these into some equations as we continue up through the next couple of weeks. So I know you're all thinking, yay, math. Yep, it's going to happen. It's pretty easy stuff. If I can do it, anybody can do it. So now we're just going to zip right into gas laws. And why do we need to know gas laws as respiratory therapists? Gas laws are key to respiratory therapists. It's something that your understanding of which you'll use every single day, whether I'm doing a pulmonary function test on a patient, whether I'm humidifying gas and then pushing it into their bodies with my ventilator, whether I'm looking at diffusion across the alveolar membrane, if I'm looking at pressure gradient to oxygenate somebody and I need to know the alveolar to arterial gradient, things of that nature. All these gas laws are going to start playing into that. And you might not at the bedside think, oh, I'm physically using Boyle's law today, but it's going to be so second nature to you that you just do it. And at the end of the day, you think, well, yeah, I exercise those gas laws today. So we'll start with the ideal gas law. First thing we'll talk about ideal gas law is an ideal gas. As you read there, it's an idealized model for real gas that have sufficiently low densities. The condition of low density means that the molecules are so far apart they do not interact except during collisions, which they're effectively elastic. Okay, so when we talk about being elastic, that we're not losing energy or form as they move with each other. And they're at a constant volume and pressure is proportional to the temperature. So next up is the actual ideal gas law. So we have PV equals nRT. So P is going to stand for pressure, V for volume, equals N is for the number of molecules in moles. Sorry, I'm getting a little scratch in my throat there. Just a second. I might silence just a second. I'm going to grab a drink. Sorry. Okay, I'm back. So I give you a little picture there to look at while I'm coughing in the background. So there we have pressure, and then we have volume, and that equals number of moles in whatever gas we're looking at. R is that gas constant, and then T is for temperature. So now we break down the ideal gas law, and we're going to look at 3 specific laws, and it's just relationships of pressure, volume, and temperature, okay? So then the first one up is Boyle's law. So as you see there, that P1 and V1 equals P2 and V2. So here you can see that there's a relationship between pressure and volume. I've got a picture of it, so don't get nervous. The next one up is Charles' law. And so we have, notice here, we just looked at pressure and volume relationships. Now we're looking at volume and temperature relationships. And so we're going to deal with that one. And then the last one is Guy-Lussac's. And now we're looking at pressure and temperature. So if we start clear back here, there we have pressure, volume, and temperature with some how many and a constant. And then we start breaking down, and these gentlemen all define these different relationships between these 3 with these various equations. The last one, which is kind of a curveball to throw in there, is Dalton's law of partial pressure. And what Dalton figured out is that if we have the sum of all the pressures together, that gives us the pressure total. And so an example of Dalton's would be in our atmosphere, we have 80% nitrogen and we have 20.9% oxygen, and the balance is CO2, argon, and that sort of thing. All those pressures come together and they don't react with each other, thank goodness. But all those pressures come together and that gives us pressure total, or atmospheric pressure, wherever we're standing. So these different conditions of gases that we can have in respiratory therapy. And so here with our little lung picture, you can see that we can have atmospheric pressure outside, and as that diaphragm deflects down, it's going to create a negative pressure within the lung. And so those lungs, once that negative pressure as the diaphragm deflects down, is going to draw gas in from the atmosphere, and those lungs are going to inflate. And that's an active thing. It takes muscle to do that and energy. But what you'll find is when you're breathing just relaxed and slow, it's a pretty passive thing. It's just a relaxation of that muscle as it deflects back up. Obviously, if we're blowing out the birthday candles or doing something like that, that's an active thing as well. But for the most part, if we're at rest, it's a pretty passive thing. So we have a count of 1 to get that gas in, and then a count of 2 to 3 usually to get that gas back out. Another form of gas in respiratory is pressurized gas. And so just an example of that is we have gas in these tanks, and there's a nice sampling of the different oxygen tanks out there. But this is gas under pressure, and this gas under pressure can do work for us. We can flow that to a patient to give them oxygen. We can power a ventilator if it's a pneumatic power ventilator. Then that gives us a ability to do work with the pressurized gas. We can inflate a non-inflating resuscitation bag, and that can do work for us as well. So gas under pressure. And then we can have gas in a liquefied form. And there's a picture of liquid oxygen. And so that system's important to us because it's a lot more concentrated, so it's a lot more useful to us. And we'll talk about calculating the usefulness of that in another week. Okay, so talking about Boyle's law, here's a picture of, to help you kind of get an idea of what Boyle is saying. Notice on the left side you have your pressure and your volume. It's all at a given pressure and at a given volume. If we compress that, so let's say that we take that pressure by half, that volume and half it, then that's going to increase or double our pressure. So I'll say that one more time. If over on the left-hand side is a volume of 1 and a pressure of 1, if we compress that volume down to a half of 1, then that pressure is going to double. So as you can see, it's a relationship between those two. If we compress it, then the pressure goes up and the volume goes down. So here we have Charles. And so now we're looking at, let's zip back here to Charles. So we have volume and temperature, okay? So if we come back here and we have a set volume inside that balloon of gas, if we cool that gas, then it's going to contract and slow those electrons or those atoms, down, and it's going to contract down. Versus if we put that same volume in the boiling water and heat it up and excite those, then we see increase of volume. And then on to Gay-Lussac's, or talk about Gay-Lussac's. Now we're talking about pressure and temperature. And so notice that if we increase our temperature, then we increase our pressure. And notice inside there that the constant is we have the same amount in there. And again, we're exciting those molecules, and so we have an increase in pressure. Couple of things to keep in mind when we talk about a standard number for atmospheric pressure. Unless otherwise defined, that number is going to be 760. For most of your equations, if we're just looking at good standard atmospheric pressure, keep in mind 760. And then with body temperature, that's always going to be in this business. The SI unit is in Kelvin, but we're going to define body temperature in centigrade. So it'll be 37 degrees. centigrade. And your atmospheric pressure, that's going to be in millimeters of mercury. So how a good old mercury barometer works is, think of atmospheric pressure as a column of air, the height up to our atmosphere. And that column of air pushes down on that mercury and pushes that mercury up a side of the flask, and that's where you gain that measurement from. Now that you're in the medical business, we're going to always refer to body temperatures in centigrade. And like I say, what we're used to in Fahrenheit, we're going to always define that as 37 degrees centigrade as your regular, normal, expected body temperature. So on to questions. I'm just going to take half a second and just take a look at this week's assessment, make sure that I covered everything we wanted to cover. So just a couple things to review. Temperature is back here at the body temperature. Remember that temperature is the measurement of the amount of heat that's there. Keep in mind when we're talking about solids, liquids, and gases, that solids are the most dense state of those three. Trying to think of an example. One example, going back to how you guys can start thinking about application of some of these equations. One application of these equations that I use quite often is pulmonary function test. And when you do pulmonary function tests, there's several different tests that you can perform. And I'll just talk to you about this as I'm just reviewing the quiz and making sure that I got everything I want to cover tonight. Anyway, we look at Boyle's law. So let's sit back here to Boyle's law. So we have pressure and volume. One thing that we do on a pulmonary function test is we have pressure and volume, and we have a box that we put the patient in. We actually close the door and have them do a couple of maneuvers. And when you're doing your clinicals, you'll have an opportunity to hopefully see it, and it's called a plethysmography. And say that 3 times fast. It's plethysmography. And we'll put the patient in the box. And we know inside the box, we know the volume of that box. And we know the temperature inside that box. And so that's constant, so we can eliminate that inside and outside the box. On the outside, we've calibrated that device to the pressure for the day. And so what we're looking for is, as they start doing those maneuvers, the known volume of inside the box, and as they go through those maneuvers, we look at the pressure change inside and outside of that box, and from that we can calculate very accurately the actual lung volumes of that patient based on those pressure changes. So that's one application that you can use on a daily basis of Boyle's law, and one that whenever I'm doing pulmonary function tests on my patients at the hospital, one that I definitely use. So Christy agrees that we should review the quiz. Sorry, I missed your guys' chats there. And Jill agrees, and I'm sure everybody else will agree with that one. So in review, we kind of zip through that kind of quick because I get a little long-winded when I'm talking about the housekeeping stuff for this first one, but we'll slow it down with the next subsequent lectures as we continue to put all this stuff together. Yeah, Jill, because we only have 2 in the lecture, looking for extra points to show up for the lecture. You guys are smart to ask for that. That is one thing. I had a student this morning that didn't do great on last mod and wanted to know if she could do anything extra. Unfortunately, Jill, that we don't allow per IU policy. I'm not making the rules, but per IU policy, no extra credit. So having said that, just do your assignments and you'll be fine. I promise you. So quick review, the states of matter, changes of matter, measurements of those different changes. When I talk about that, talk about definition of pressure, definition of temperature, make sure you know what changes those matters inside and out. Know the different parts that make up those laws, the Boyle's, Charles, Guy-Lussac's, and Dalton's laws. Be able to identify those, and the Grand Poobah, the ideal gas law, what all those are derived from. Make sure you know all those different pieces of those, which all those letters stand for, which I showed you. And you should do fine on all that. I'm looking. Jill, Christy, you guys have any other questions tonight before we cut you loose and let you do your discussions and read your chapters if you haven't? Okay, Jill, no question. Okay. Make sure you read those chapters, and I know it takes a little time to work your way through some of those videos and so forth, but I know that if you'll do that, you'll be just fine come quiz day and work through those assignments. They all just kind of when you lost my train of thought. Probably wasn't important. Christy, when I say ideal gas law, do you have some more to that question? Yes, I am. So ideal gas law is PV equals nRT. Yep, that's exactly. And that's what those other three Boyle's, Charles, and Guy-Lussac's, those other three that I showed you, all those come from that gas law. So if you need to calculate any of those, you could really calculate any of that stuff off of the ideal gas law. What those other equations do is break those down further. So that you have a standard temperature or whatever, you can just solve for pressure and volume at that point. So we'll give you opportunities as we work through this to work through those. So as far as that's a good question, Christy. So as far as once we finish up with this lecture, I have another class that I'll be lecturing on in about 10 or so minutes. I just wait for the email to come back from Zoom to tell me that that's up. So what I do at that point is I'll send out an announcement that says the lecture's up, and then it'll be on the live lecture off your homepage for the course on Canvas. You can click on live lecture and click up that link, and sometimes it's up within like 5-6 minutes, and I can get all that done before my next lecture starts. And sometimes it takes a little bit longer, and so I have to do it after all my lectures for the night. So there's the SI unit. Jill wanted to see that slide again, and I believe this similar looking chart is in the text, but it's something you can Google as well and go into like Google Images, and there's all kinds of different variants on that. So get used to those. So that one is a good one to look at, and that one's a good one to look at as well, so that you make sure you have a handle on what all those stand for. And we'll work on some more of this as we start into this week. So, you guys have any other questions I can answer for you? If not, thanks for joining me tonight. Those of you that are tuning in on the recorded one, if you guys have any questions, fire me off an email, and I'll be happy to help you out. That's what I'm here for. So let me help you, and don't be bashful about firing off questions to me. I'm here to help you. Okay. All right. Thank you all, and appreciate you tuning in. And we'll see you for sure next week, same time, same place. And as you guys start into your discussions and your assignments and preparation for your assessments, let me know if I can be of any help to you. And do your posts and have them all on time. And with that, we'll sign off. Thank you all. Have a good night.